welcome back to Learn Extra Exam School, and I'm very delighted to tell you that we've been getting some questions, and it seems like graphs are an area that need some help. So we've had Facebook requests for graphs, and we're certainly getting phone calls that are requesting graphs. So we're going to finish up this question. I'm going to address the Facebook question that came through. That's what resulted in us using this question to try and explain some of the issues. And then we will move on to another graph question, because it seems, and remember, graphs are quite a big, they call them functions in your breakdown. And I think off the top of my head, you're probably looking at about 40 odd marks on functions. So it's a very important section to be involved in. Okay, so let's have a look at the rest of this question. It says the graph of f is shifted 2 units to the left. Write down the equation of the new graph. Now, this is quite important. I would like to just, great, it does help if one has the pen in hand, mention that if we're looking at a graph of y equals x squared, it would look like this. As soon as we have y equals x minus 1 squared, and you actually draw it, what you find is that it shifts to the right-hand side. So it always moves the opposite way to that sign. So if it's going to shift to the left, this particular graph, it would have had to be a plus 1, say, for example. So y equals x plus 1 all squared. And that would make that a minus 1. So if we're going to shift this 2 units to the left, we are moving this way, which means we are adding on a number. So if we're moving 2 units to the left, oh my gosh, that was clever, I nearly lost the question. What we're actually doing is we're saying it's now going to be y equals 2, and I'm going to put in an extra step, which I normally would not have done, but I think, you know, since we're tidying up all loose ends at this stage, we would add 2 to shift it that way, and then we would have minus 8. And I would have gone straight to the next step. I wouldn't have even shown that one. I would have said it's x plus 1 all squared minus 8. Now, if we look back to our graph, our axis of symmetry would have been at minus 1. Does that make sense that it shifted 2 units to the left? Most definitely yes, because it's a plus 1. If it goes to minus 1, it's shifted 1, 2 to the left. So that's definitely okay. We can handle that. Okay, so simple, straightforward. Let's see what the next question holds. And this one is particularly nice. It says, given that h of x is 4 to the x, and f of x is that, show algebraically. Now, what we found in the last few years is the algebraic manipulation has not been as rigid as in previous syllabi. And so this is a nice opportunity to ask algebra in the middle of your functions. So let's have a look. We have h of x, it's equal to 4 to the x, and what they're asking me is to show that h of x plus a half is equal to 2 lots of h of x. So it's a bit of functional notation and a bit of algebraic manipulation all thrown in together. So now what I would do in order to work with this is I would work this left-hand side out first of all, to the simplest point I can get to, and then I'd move to the right-hand side. So if this is the case, what I'm asking you to do is I'm asking you to replace that x with x plus a half. So this would become 4 to the x plus a half. Well, can we do anything to make this look better? Well, yes, we can. This is an exponential equation, an exponential expression. So we can take the 4 and we can make it 2 squared, all to the x plus a half. And of course, from exponents, we know that we would now multiply this exponent into both of them. So we would get 2 to the 2x, and 2 times a half is actually going to be 1. So we have this there, and I think that's pretty simple. So let's see what we can do on the right-hand side and whether we can get a bit further on. Right, so on the right-hand side, they're telling me it's the same as 2 lots of h of x. So 2 lots of h of x, and h of x was 4 to the x. Well, is it the same? Well, we're going to have a look over here, and we're going to say, well, that's the same as saying 2 times, and that's going to be 2 to the 2x. Now, you say to yourself, well, okay, that doesn't really look the same, but remember, we've got a law that says if I have a to the m times a to the n, if the bases are the same, I'd write the a, and then I would add the exponents. So what is the exponent here? It's actually 1. So it will become 2 to the 1 plus 2x. And of course, does it matter if we do it that way? When we're adding, it doesn't matter the order we do it in, so we can reverse it. And then I can conclude that the left-hand side equals the right-hand side. Now, if they're asking you to show, or they might even use the word prove, whatever you do, do not work with it as one statement. You must separate it to left side and right side. There is a technique that some teachers teach where they say, okay, assume it not equal, and then you show it is equal. That's fine if you've been shown that, but I'm certainly not going to show that now on television, because all I'm going to do is confuse the people who've never seen it before. But generally, as a rule, I would encourage you to work left-hand side, right-hand side, and then to conclude the question by saying left-hand side equals right-hand side. Okay, so let's go to the next page, and this is where the question came from. Busu Ivan Dube sent us in, please discuss quadratic graphs. Now, hopefully, at this stage, you understand how to use the format y equals a, x minus p all squared plus q. So let's talk now about the format y equals ax squared plus bx plus c. How would that make a difference? Well, it depends. One option is to take this format and change it into this format by completing the square. Sometimes a little hair-raising, but it's a one way to go about it. The other option is to just work with this. So since Ivan asked this question, let us have a look at one, and I'm just going to make one up, so hopefully it's a nice balanced one. We'll see shortly. I'm not going to make it too hideous because we don't really want to scare you all senseless. Something like that, which is quite easy, so it's not going to get some ugly fractions or anything like that. If we were going to take this and move to this format, we do what we call completing the square. Now, there are many methods of completing the square. I like a particular method, which probably most teachers don't do. I know that some of my colleagues use it. So what we're going to do is, what I would do is I would move the 8 over. But let's assume we're not doing that way. So what you would do is you would start over here and you'd say y equals, and you would know that you need to have the coefficient of the x squared equal to 1. So the first thing you're going to do is you're going to take the 2 out as a common factor, leaving yourself with x squared minus 2x minus 4. Okay. Now, of course, if we multiply out at any stage, we must be able to get back there. Yes, 2x squared minus 4x minus 4. All's looking good. Now, the next thing you would do is you would take these two and you would separate them, because what you want to do is complete the square on that. So what I mean by complete the square, we take the coefficient of x, which is minus 2, we multiply by a half, which gives us minus 1, and we square it, which gives us plus 1. We can't just stick a plus 1 in, so what we do is we subtract 1. That means that if I multiplied this out, I'd get back there, and if I multiplied that out, I would get back there. So then this is equal to 2, and now what has happened is this has become a perfect square. So it's now x minus 1 all squared minus 5. And then to bring it back to the format we were working with earlier on, I would times that 2 inside here, so we'd go to that and that. And of course, now you can see I know the shape, I know the axis of symmetry, I know the turning point, and we can go and find the x and the y intercepts very easily. So that is the one approach. But to be honest, unless they specifically asked me to use completing the square, I would not do it. It's much easier to use an alternate method. So let's look at an alternate method, and let's take another easy-ish one. I don't want to, as I say, spend all your time doing heavy arithmetic when we can be dealing quite nicely with a simple question. I hope that's simple. We'll see shortly. Say I ask you to sketch that graph. Well, here, a x squared plus bx plus c is the format. The a value once again determines shape. And just like the previous one, it does exactly the same thing. So if it's positive, it smiles. If it's negative, it sulks. So in this case, it's positive, so it's that one. Then, what does the c do? The c is actually the y-intercept. So I already know my y-intercept is 0 for x minus 2 for y. And the b value, well, that's a little bit more complicated. The b value actually affects the axis of symmetry, which side of the y-axis it will occur, in conjunction with your a value. So basically the shape and the y-intercept's easy enough. The third one, you would get your axis of symmetry. Now, the formula that you would have been shown, and of course you can always use calculus, that's what's so exciting now about being in matric. You don't have to go back to this format. I'll show you why this happens in a minute. So x is equal to minus b over 2a means you would go along, you would say x is equal to minus, your b value was minus 3, over 2 times your a value, which is 2, which means we have 3/4 as our axis of symmetry. And then the fourth thing I would do is I'd find the turning point, which I would do by substituting x equals 3/4 into the equation. So I would go y is equal to 2, 3/4 all squared, minus 3 times 3/4, minus 2. And of course the calculator would be great for that. You've got fraction buttons on your calculators. The sharp one I can pull up for you now and show you how it works. But definitely I'll do it without a calculator as much as possible, because sometimes they do say without using your calculator. Right, so this becomes y equals 2, and this becomes 9/16 minus 9/4 minus 2. And of course that becomes 9 over 8 minus 9 over 4 minus 2. And we can take it all over 8 now, so it's 9 minus 18, and that's going to be minus 16. And of course, if we're going to tidy that up a little bit more, it's going to be minus 25 over 8. So we have hideous turning points. I do apologize. This is what happens when you make up a question. But you know what? You're tough. You're writing tomorrow. I don't think a little bit of fractions are going to scare you at this stage. Right, and then the only remaining thing I have to do after that is to find the fifth thing, which is your x-intercept, and that's actually why I chose it. I try to find myself nice x-intercepts. Maybe it would have been easier to find a nice turning point. All right, so your x-intercept, you're going to let y equal 0, so 0 equals 2x squared minus 3x minus 2. And then that is going to become, if we factorize it, 2xx, 2 and 1, a minus and a plus. And so your x is minus a half, or your x is 2. Coordinate minus a half, 0. Coordinate 2, 0. And of course we know our check is, are those x values an equal distance from there? And of course that we pick up when we actually sketch it. So let's try and sketch it. I'm going to have to move this page up and down. Oh dear, that wasn't clever at all. I chose the wrong choice. All right, let's first do this. Let's just cut it. Cut, and then let's go back here to this one and get this one. Okay, right, let's get ourselves an axis going. I'm not going to make it a very huge axis, but good enough for this purpose. And what I know that I must go, let's not make it too small. 1, 2, 3, 4. Of course, please don't do what I've just done here. Use your rulers. Sketch accurately as much as you can, not to make a masterpiece, but certainly have your scale consistent and all those kind of things. And remember the labeling. For matric marking, I've always found that if they're going to penalize you, they take one question and they penalize you 1 mark for not labeling things correctly. So they won't consistently do that to every question you do on graphs, but it's a good idea to actually look at it. So this is going to be at minus a half. This one is at 2. Okay, and your axis of symmetry is at 3/4, which is about here somewhere. Let's go and find ourselves a axis of symmetry. And if you look at that, that's going to be a half plus 3/4, so it's going to be 1 1/4, and that's 1 1/4, so it makes perfect sense. And we have the pleasure of our turning point, which was an absolute delight. That looks to me like -3, -3 and an 1/8. I like to look at it like this. It just makes it easier to plot it. And of course, they're not expecting masterpieces, so over here I'm going to go 3/4 with negative, was it 25, yeah, over 8. Okay, I know that this was at -2 because I did that earlier, and so there's my parabola. Right, so hopefully that helps you. It doesn't really make any major difference in the sense of how we approach it. It's just a little tweak with this formula here. And just before we go to ad break, I just want to mention one thing, because this is, that wasn't clever at all. Let's take y equals ax squared plus bx plus c. Now hopefully from your calculus, and in fact I'm sure from calculus you do know that a stationary point is found by finding the derivative equal to 0. So if we find the derivative of this, it's going to be 2ax plus b. Now, for a stationary point, we let the derivative equal 0. So 0 is equal to 2ax plus b. And so minus b is equal to 2ax. And at this stage, I'm sure you're all excited. You've seen this before. You can see this is where that formula could have come from. Of course, it also comes from completing the square on ax squared plus bx plus c. But this is a nice way to show how they get that formula. So, of course, you could have always used your calculus to find that turning point by finding the derivative, putting it equal to 0 and solving. They will never stipulate for you what method you must use to find a turning point, unless they were asking you to complete the square to do it, then they would. But really, if you want to use your calculus because you find it easier to find things like that, that's great. Okay, great. So let's go to the ad break. And after the ad break, we will carry on with functions, and in particular, we will look at cubic functions, which is another question that has come through on Facebook. And we've got a caller, I think, on the line for that next question. So it'll be great to chat to, I think it's a him, I'm not sure, him or her. But anyhow, we will speak soon. So enjoy your break and come back ready to do some more functions. I think by now you've got graphs coming out of your ears. Right, see you later.